Okay, greetings again. Okay, hopefully this is a quick video. Let's remember a unit circle. Okay, notice, here's angle theta, and here's this point on the unit circle, and we break in, we make our triangle, and this is our x component and our y component. Remember, this is a right triangle. This is perpendicular down to my x-axis. Excuse me. So sine of theta, sine is opposite over hypotenuse or radius. So sine of that theta equals y over r. Well, let's solve for y. Well, let's get rid of this divide by r. So we're going to multiply both sides by r. R over r cancels out, so y equals r sine theta. Y equals radius sine theta. If theta is 50 degrees, and this is, let's say, 9, my radius is 9, that would be 9 times sine of 50, okay? All right? Anytime you've got a vector or a radius, your vertical component will be that times the sine of theta. That's your y, okay? Just by using knowing your sine of theta, okay? All right, so we solve for y. It's 9 sine of theta, r sine theta got me my y. Guess what we just solved for? If this was some triangle, we just solved for the height of that triangle, right? What's the height of a triangle? It's the perpendicular distance from the vertex to the base, okay, to the opposing base. Remember, over here, if you've got an obtuse triangle, it's the extended base. Here is your height, okay? Right? Remember, your sine, if this is the unit circle, this still works. The sine's still positive in quadrant 2 or 1, even though we're over here, okay? So remember, r sine theta, that'll be my y component. That's going to be the height or altitude of a triangle. We need that height for our formula. What formula might you ask? Area of a triangle, right? The area of a triangle is base times height divided by 2, or 1/2 base times height. Okay? Base, and now we know what the height is. All right, so we've traditionally been blessed with right triangles, base times height. But now we're going to have to figure out what the height is of this triangle. So in this case, it's this vertex to the perpendicular to the opposite base. Okay? All right. Well, let's just make this the origin of our unit circle. So this, let's say, is our radius. And we're going to just make, just like we did, pretend it's like a unit circle. This is what? Here's a radius. We came down here. This is my x and this is my y. All right? So sine of that theta equals my base, right here, the whole base, a times what? Remember what the y component is? Remember, y component is r sine theta. Okay, so this is my unit circle. It's going to be b sine of that theta there. Okay, which is going to be c. Okay? Notice you're going to have 3 different formulas that mean the exact same thing. Just like the law of cosines. We have a squared equals or b squared equals. It just doesn't really matter that much. It's basically, you know that this theta is going to equal, your area of your triangle will be your base, whatever it's labeled, times this component, sine of theta. Okay? All right? So in this case, the area of this triangle, so let's see here. Where is that? Okay. All right, so let's do the area of this triangle real quick. Sorry about that, I got flustered. All right, so remember, 1/2 base times height. Okay, so the area of this triangle here, where CAB, will be 1/2. What's my base? A. Okay, what's the height? that y component is going to be, remember, let's theta or angle C. Okay, and that's going to be r sine theta, and this r is b sine of C. Okay, so that's one of the formulas. They're all the same. Whatever you label your base, this could be 9, and this, so this is, we plug in numbers for all this. Okay, all right. Here's the same formula. Now I've just rotated the angles. Okay, let's find the area of this triangle. It's going to be 1/2 base, which is C, times my height. Again, here's my radius here, A. R sine theta, A sine of angle B. Okay? So your book would have that 1/2 AC sine B. Notice it's much like the law of cosines where you've got components A, B, and C. If your sides are A and C, your angle's B. Okay? All right, in the last cases, they're all the same, right? Just switching the letters up. Okay? There's my height, 1/2 base. The base is little b, actually. Here, that works out, huh? And the height is going to be, again, here's my radius. There's theta. Here's the origin on my unit circle. R sine theta. BC sine of A. Again, notice, if you're taking the sine of capital A, it's going to be 1/2 BC. If it's going to be sine of capital B, what letters are left? A and C. Okay? So, whatever two small letters, the missing letter out of A, B, and C is there in capitals. Okay? But all it is 1/2 base times height, and height is what? R sine of that angle. Okay? This is 10. This is 9. This is, let's say, 35 degrees. Okay? The area of that triangle is going to be 1/2 my base of 10. So we don't really need the letters. Here's my base. And this height is what? R sine of that. Your vertical component is always going to be your radius times the sine. Okay? So R times R sine of 35. Now we can find the area. Now we can find the area of triangles that are not right triangles. So just come on in, Carl, and say hi to everybody. And wrapping up the business. That's all we have for today, all right? All right. I didn't lock the door. I didn't put the production in progress sign, okay? All right. That's it.